Hi guys, I'm Ryan, and in this video we're going to go over some more complicated integration. Okay, so AASLs and AAHLs, you need to know this, and also AIHLs, you guys gotta need to know this. Okay, so back in video 5.5 we talked about some simple integrals, right? So why is this a simple integral? Let's say this as an example. Why is it a simple integral? Because as you can see, the chunks are broken up with addition. Okay, number one. And number two, you can see that numbers that are multiplying are not within the x, right? It's outside, it's not in the x. Okay, so therefore these kind of integrals are going to be simple because you can break it up into two chunks and you can take out the numbers. Okay, so in this video we're going to talk about more complicated ones. So some complicated integrals will include functions that are composite functions, right? So if you have done the functions unit, you should know what is a composite function. So as you can see here in example 1, this is a complicated integral because the number is multiplying with the x. Okay, so this is a complicated integral. And also in example 2 here, you can see that there's like a fraction and the x occurs in two locations, right? So it's in the top and in the bottom. So these are the complicated integrals. Okay, so to do complicated integrals we need to use a technique called integration by substitution, or a lot of people call it U-sub. Okay, so the general steps of doing integration by substitution is 1, 2, 3, 4, 5 steps. Okay, so there's 5 steps. Okay, step 1, you need to let u equals to something. Okay, and how we do these steps, I'll have examples to show you later. Okay, so just follow along. So step 1, let u equals something. Step 2, find du over dx and isolate the dx with algebra. Okay, step 3, replace dx with du. And then number 4, sub u into the equation. And step 5, simplify and do the integral. Okay, so how do you execute these steps in practice? So let's look at the first example here. Okay, first example. So first step is to let u equals to something, right? So we're gonna let u equals to 3x. Okay, and hey, you may ask me, hey, how do I know that I need to let u equals to 3x? How come it's not u is equals to sine 3x, right? How come it's not u is equals to x squared? How do I know? Well, you follow along and you will know later. Okay, I'll tell you the steps on how you can find u is equals to 3x. Okay, but for now, let's just say that let u equals to 3x. Okay, and then step 2 is to find du is equals to dx, right? So du is equals to dx will be equals to 3, right? How do I get this? I need d both sides, so du and then dx, and du, if I d everything here, right? So then I'll get du is equals to 3, right? So therefore, that's why du over dx is equals to 3, right? So to write it out, du over dx is equals to 3. Move the du over 3 is equals to dx, okay? So how do I... So step number 2, okay, we need to find du over dx, right? So look here, du over dx and isolate x. So if we du, right, what do we get? If we take the d of this, we get 3, right? So that's why du over dx is equals to 3, okay? And then we need to isolate the dx, right? Isolate the dx, right? Isolate the dx. So here, moving this to this side and then move the 3 down to the bottom here, we get dx is equals to du over 3, okay? So then step 3, replace dx with du, right? So step 3 is going to be replacing this dx here with du over 3, right? So we need to replace this here, or put this into here, then we get this, right? Okay, and then step 4, sub u into the equation. Okay, we said u is equals to 3x, right? And we see 3x here, right? That's why we're subbing in u here. Okay, and then step 5, simply do the integral, right? So here, simplify and do integral. Can I simplify this anything? Well, I can take the 1 over 3 out, right? And if I take the 1 over 3 out, it's just going to be integral of sine u, right? How do you do integral of sine u? Well, very simple. Look at your formula booklet, right? Under 5.10, okay? Integral of sine x is equals to negative cosine x plus c. So therefore, I know if I take the 1 over 3 out, after the integral, it's going to be negative cosine u, right? So that's why the result is negative 1 over 3 cosine u. And then finally, you need to add the plus c. Remember that, okay? So that's done for example number 1. Okay, moving on, example number 2. Okay, so example number 2, I have x plus x squared plus x over x squared plus 1. So we're going to let u is equals to x squared plus 1. Again, how do I know this is x squared plus 1? I'll tell you later, okay? But this is the hardest part. Basically, thinking of what to substitute is the hardest part of u-sub integration, okay? So then step number 2, find du over dx and isolate dx, right? So again, if I take the d of this, right, what I get du over dx is equals to 2x, right? Because I just d this, okay? If you don't know how to do it, you got to watch back the previous videos on how to do derivatives, okay? And then if we isolate dx with just algebra, right? Move this to this side and then move this to this side. I get dx is equal to du over 2x, okay? And then since this is dx, since this is dx, I can substitute this into here for step 3, right? Substitute du into dx, right? So I get this here, okay? Step 4, substitute u back into the equation. Step 4, substitute u back into the equation. I know u is equal to x squared plus 1, so I see x squared plus 1 here. Therefore, I'm going to replace this with a u, okay? And then finally, step 5, simplify and do integral, right? So here, I can see that my x and this x can cancel, right? So therefore, I'm going to cancel this x like this here, okay? So what do I get? I get 1 over 2u, right? 1 over 2u, because these two will multiply with each other, and this du goes here, okay? And then, again, since I have a number here, I can take out the 1 over 2, and I'm going to left with 1 over u in here in the integral after I take out the 1 over 2, right? So how do you do integral of 1 over u? Okay, again, look at your formula booklet, 5.10, okay? 1 over u is here, right? Integral of 1 over u becomes ln u, okay? So ln u, be bam, bam, right there, like this. So 1 over 2 ln u, okay? And then and then you need to substitute. Remember, this is important. We want to express our answers back with x, okay? We don't want any u's, okay? So therefore, we need to replace this u back with x squared plus 1. So this is our final result, okay? So now to the $1 million question. How do I know what to sub in for u, okay? So the short answer is by experience, okay? There's really no right way, but it's by experience. This is the hardest part of integration by substitution, and that's why integration is one of the hardest units. It's because there's no set ways on how you do the substitution, okay? But the general rule of thumb you can say is, number 1, you always want to substitute stuff inside brackets, okay? Or number 2, sub exponents usually, okay? And number 3, sub stuff in the bottom. Okay, usually it's like this, okay? And number 4, if your math is a little better, you should be able to plan ahead. As in, you want to find a substitution here such that after you do the derivatives, right, you can see that something would cancel out. In this case, it's going to be the x and the x, okay? So it requires you to think ahead to step 3 first, see and think that what do you need to substitute here such that after you put it into the integral, it will simplify to something very simple that you can simply look at your formula booklet to integrate, okay? So step 4, so the 4th trick, right, to integration by substitution is think ahead on how to simplify, okay? So you want to substitute something that you can simplify. So to give you a false example, if you substituted, let's say you want to do u is equals to x squared in this case, right? Then du over dx will be equals to 2x, right? So would 2x be able to simplify here? Well, let's try, okay? So let's say you didn't know what to substitute and you thought that substituting u is equals to 2x, or u is equals to x squared is correct, right? So if we did that, then it's going to be x over u plus 1, right? And then this will be dx, right? And then, it's going to be du over dx equals to 2x, right? So that means here it's going to be du over 2x, right? Again, these will cancel out, right? Now we have 1 over 2u plus 2, right? So then we need to do an extra step here, factoring out the 2 from the bottom, right? U plus 1 du, and then you can get this, which is going to be 1 over 2 integral of 1 over u plus 1 du. And as you can see here, the result here is this is not a simple integral that you can see on the formula booklet, so you know that this is the incorrect substitution, okay? So yeah, that is it for this video. If you guys have any questions, please leave them down in the comments below, and if you guys like the video, please give this video a thumbs up, and that's it for this video. Thank you.